Good morning and welcome back to another riveting video about the Nuclear War Survival Skills book by Kristen H. Kearney. Um, so I'm covering this book in order to keep in compliance with my agreement with Skyhorse Publishing. I have to show the front of the book, and I acknowledge that Skyhorse Publishing did give me authorization to reproduce this book in video format. So I mentioned this in a couple other videos. I know this is intensely boring for most people to listen to me narrate this book. Please feel free to pause the video. It seems to be showing up pretty well on YouTube, and pause it and read through the book. That's totally fine with me. Won't hurt my feelings a bit. This isn't monetized or anything, so please feel free to do that. So without further ado, we're going to get into chapter 1, which is the myths and facts, I believe. That's the title of it. Okay. Yeah, so the dangers from nuclear weapons, myths, and facts. Okay, so let's see here. This one has some illustrations also, so it'll get a little bit more interesting, hopefully, but I'll try and make it anyway. Okay, so an all-out nuclear war between Russia and the United States would be the worst catastrophe in history. A tragedy so huge it is difficult to comprehend. Even so, it would be far from the end of human life on Earth. The dangers from nuclear weapons have been distorted and exaggerated for varied reasons. These exaggerations have become demoralizing myths believed by millions of Americans. While working with hundreds of Americans building expedient shelters and life support equipment, I have found that many people at first see no sense in talking about details of survival skills. Those who hold exaggerated beliefs about the dangers from nuclear weapons must first be convinced that nuclear war would not inevitably be the end of them and everything worthwhile. Only after they have begun to question the truth of these myths do they become interested. Under normal peacetime conditions, in acquiring nuclear war survival skills. Therefore, before giving detailed instructions for making and using survival equipment, we will examine the most harmful of the myths about nuclear war dangers, along with some of the grim facts. Myth: fallout radiation from a nuclear war would poison the air and all parts of the environment. It would kill everyone. This is the demoralizing message of On the Beach and many similar pseudoscientific books and articles. Facts. Well, here I'll show the illustration first. So yeah, this is the surface burst. In a surface or near surface burst, the fireball touches the ground and blasts a crater. And it just shows basically, light and heat radiation, initial nuclear radiation, wind direction, fallout particles starting to fall. This is from the Oak Ridge National Laboratory. Facts. When a nuclear weapon explodes near enough to the ground for its fireball to touch the ground, it forms a crater. See figure 1.1. Many thousands of tons of earth from the crater of a large explosion are pulverized into trillions of particles. These particles are contaminated by radioactive atoms produced by the nuclear explosion. Thousands of tons of particles are carried up into a mushroom-shaped cloud miles above the earth. These radioactive particles then fall out of the mushroom cloud or out of the dispersing cloud of particles blown by the winds, thus becoming fallout. Each contaminated particle continuously gives off invisible radiation, much like a tiny X-ray machine while in the mushroom cloud, while descending and having fallen to Earth. The descending radioactive particles are carried by the winds like the sand and dust particles of a mile-thick sandstorm cloud, except that they are usually blown at lower speeds, and in many areas the particles are so far apart that no cloud is seen. The largest, heaviest fallout particles reach the ground first, in locations close to the explosion. Many similar particles are carried by the winds for tens to thousands of miles before falling to Earth. At any one place where fallout from a single explosion is being deposited on the ground in concentrations high enough to require the use of shelters. Deposition will be completed within a few hours. Okay, so I'll wait to go over this figure. The smallest fallout particles, those tiny enough to be inhaled into a person's lungs, are invisible to the naked eye. These tiny particles would fall so slowly from the 4-mile or greater heights to which they would be injected by currently deployed Soviet warheads that most would remain airborne for weeks to years before reaching the ground. By that time, their extremely wide dispersal and radioactive decay would make them much less dangerous. Only where such tiny particles are promptly brought to Earth by rainouts or snowouts in scattered hotspots. The later dried and blown about by the winds. With these invisible particles constitute a long-term and relatively minor post-attack danger. The air in properly designed fallout shelters, even those without air filters, is free of radioactive particles and safe to breathe, except in a few rare environments, as will be explained later. Okay, so the figure 1.2 shows the decay of the dose rate of radiation from fallout from the time of the explosion, not from the time of fallout deposition. This is hours, and then the dose rate, Roentgens per hour. So it's basically 1,000 here, 1 hour after, 2 hours after 480, 7 hours 100. So it decays pretty rapidly. This is 14 hours after and 48 hours, so 43 to 10 after 48 hours. So it decreases pretty significantly, pretty quickly. So, fortunately for all living things, the dangers from fallout radiation lessens with time. The radioactive decay, as this lessening is called, is rapid at first, then gets slower and slower. The dose rate, the amount of radiation received per hour, decreases accordingly. Figure 1.2 illustrates the rapidity of the decay of radiation from fallout during the first 2 days after the nuclear explosion that produced it. R stands for Roentgen, a measurement unit often used to measure exposure to gamma rays and X-rays. Fallout meters, called dosimeters, measure the dose received by recording the number of R. Fallout meters, called survey meters or dose rate meters, measure the dose rate by recording the number of R being received per hour at the time of the measurement. Notice that it takes about 7 times as long for the dose rate to decay from 1,000 Roentgens per hour to 10 Roentgens per hour, 48 hours, as to decay from 1,000 Roentgens per hour to 100 R per hour, 7 hours. Only in high fallout areas would the dose rate 1 hour after the explosion be as high as 1,000 Roentgens per hour. If the dose rate 1 hour after an explosion is 1,000 R per hour, it would take about 2 weeks for the dose rate to be reduced to 1 R per hour, solely as a result of radioactive decay. Weathering effects will reduce the dose rate further. For example, rain can wash fallout particles from plants and houses to lower positions on or closer to the ground. Surrounding objects would reduce the radiation dose from these low-lying particles. Figure 1.2 also illustrates the fact that a typical location where a given amount of fallout from an explosion is deposited later than 1 hour after the explosion. The highest dose rate and the total dose received at that location are less than at a location where the same amount of fallout is deposited 1 hour after the explosion. The longer fallout particles have been airborne before reaching the ground, the less dangerous is the radiation. Within 2 weeks after an attack, the occupants of most shelters could safely stop using them, or could work outside the shelters for an increasing number of hours each day. Exceptions would be in areas of extremely high fallout, such as might occur downwind from important targets attacked by many weapons, especially missile sites and very large cities. To know when to come out safely, occupants either would need a reliable fallout meter to measure the changing radiation dangers, or must receive information based on measurements made nearby with a reliable instrument. The radiation dose that will kill a person varies considerably with different people. A dose of 450 Roentgens resulting from exposure of the whole body to fallout radiation is often said to be the dose that will kill about half the persons receiving it, although most studies indicate that it would take somewhat less. Note, a number written after a statement refers the reader to a source listed in the selected references that follow at Appendix D. Almost all persons confined to expedient shelters after a nuclear attack would be under stress and without clean surroundings or antibiotics to fight infections. Many also would lack adequate water and food. Under these unprecedented conditions, perhaps half of the persons who received a whole body dose of 350 Roentgens within a few days would die. Fortunately, the human body can repair most radiation damage if the daily radiation doses are not too large. As will be explained in Appendix D, a person who is healthy and has not been exposed in the past 2 weeks to a total radiation dose of more than 100 R can receive a dose of 6 R each day for at least 2 months without being incapacitated. Only a very small fraction of Hiroshima and Nagasaki citizens who survived radiation doses, some of which were nearly fatal, have suffered serious delayed effects. The reader should realize that to do essential work after a massive nuclear attack, many survivors must be willing to receive much larger radiation doses that are normally permissible. Otherwise, too many workers would stay inside shelter too much of the time, and work that would be vital to national recovery could not be done. For example, if the great majority of truckers were so fearful of receiving even non-incapacitating radiation doses that they would refuse to transport food, additional millions would die from starvation alone. Myth number 2, fallout radiation penetrates everything. There is no escaping its deadly effects. Facts. Some gamma radiation from fallout will penetrate the shielding materials or even an excellent shelter and reach its occupants. However, the radiation dose that the occupants of an excellent shelter would receive while inside the shelter can be reduced to a dose smaller than the average American receives during his lifetime from X-rays and other radiation exposures normal in America today. The design features of such a shelter include the use of sufficient thickness of earth or other heavy shielding material. Gamma rays are like X-rays, but more penetrating. Figure 1.3 shows how rapidly gamma rays are reduced in number, but not in their ability to penetrate by layers of packed earth. Each of the layers shown is one halving thickness of packed earth, about 3.6 inches or 9 centimeters. A halving thickness is the thickness of a material which reduces by half the dose of radiation that passes through it. The actual paths of gamma rays passing through shielding materials are much more complicated due to scattering, etc., than are the straight line paths shown in figure 1.3. But when averaged out, the effectiveness of halving thickness of any material is approximately as shown. The denser a substance, the better it serves for shielding material. Thus, a halving thickness of concrete is only about 2.4 inches or 6.1 centimeters. Okay, so here's that figure. Okay, so yeah, basically it's this is 5 halving thicknesses of packed earth, or 18 inches, 45 centimeters. It's basically, 1/32 of the reduction of gamma rays if you have 5 of these. Protection factors. Illustration of shielding against fallout radiation. Note the increasingly large improvements in the attenuation and reduction factors that are attained as each additional halving thickness of packed earth is added. Okay, I hope everybody can see that. Okay, if additional halving thicknesses of packed earth shielding are successfully added to the 5 thicknesses shown in figure 1.3, the protection factor, PF, is successively increased from 32 to 64 to 128 to 256 to 512 to 1024 and so on. Okay, myth number 3. A heavy nuclear attack would set practically everything on fire, causing firestorms in cities that would exhaust the oxygen in the air. All shelter occupants would be killed by the intense heat. Facts. On a clear day, thermal pulses, heat radiation that travels at the speed of light from an airburst can set fire to easily ignitable materials, such as window curtains, upholstery, dried newspaper, and dry grass, over about as large an area as is damaged by the blast. It can cause second-degree skin burns to expose people who are as far as 10 miles from a 1 megaton explosion. See figure 1.4. Cover that on the next page. A 1 megaton nuclear explosion is one that produces the same amount of energy as does 1 million tons of TNT. If the weather is very clear and dry, the area of fire danger could be considerably larger. On a cloudy or smoggy day, however, if particles in the air would absorb and scatter much of the heat radiation, and the area endangered by heat radiation from the fireball would be less than the area of severe blast damage. Okay, so here's that figure they were mentioning. This is the air burst, figure 1.4. The fireball does not touch the ground, no crater. An airburst produces only extremely small radioactive particles, so small that they are airborne for days to years unless brought to Earth by rain or snow. Wet deposition of fallout from both surface and airburst can result in hotspots at close to or far from ground zero. However, such hotspots from airbursts are much less dangerous than the fallout produced by the surface or near surface bursting of the same weapons. The main dangers from an airburst are the blast effects, the thermal pulses of intense light and heat radiation, and the very penetrating initial nuclear radiation from the fireball. Take a drink. Okay. All right, so firestorms could occur only when the concentration of combustible structures is very high, as in the very dense centers of a few old American cities. At rural and suburban building densities, most people in earth-covered fallout shelters would not have their lives endangered by fires. Myth number 4. In the worst hit parts of Hiroshima and Nagasaki, where all the buildings were demolished, everyone was killed by blast radiation or fire. Facts. In Nagasaki, some people survived uninjured who were far inside tunnel shelters built for conventional air raids and located as close as one-third mile from ground zero, the point directly below the explosion. This was true even though these long, large shelters lacked blast doors and were deep inside the zone within which all buildings were destroyed. People far inside long, large, open shelters are better protected than those inside small, open shelters. And here's a picture of Nagasaki that doesn't really come in very well, but undamaged earth-covered family shelter in Nagasaki. Many earth-covered family shelters were essentially undamaged in areas where blast and fire destroyed all buildings. Figure 1.5 shows a typical earth-covered backyard family shelter with a crude wooden frame. The shelter was essentially undamaged, although less than 100 yards from ground zero in Nagasaki. The calculated maximum overpressure, pressure above the normal air pressure, was about 65 pounds per square inch, 65 psi. Persons inside so small a shelter without a blast door would have been killed by blast pressure at this distance from the explosion. However, in a recent blast test, an earth-covered expedient small pole shelter equipped with blast doors was undamaged at 53 psi. The pressure rise inside was slight, not even enough to have damaged occupants' eardrums. If poles are available, field tests have indicated that many families can build such shelters in a few days. That's the one I'm going to do, the pole-covered, trench-sheltered, so it's in a future video. The great life-saving potential of blast-protective shelters has been proven in war and confirmed by blast tests and calculations. For example, the area in which the air bursting of a 1 megaton weapon would wreck a 50 psi shelter with blast doors at about 2.7 square miles. Within the roughly circular area, practically all the occupants of wrecked shelters would be killed by blast, carbon monoxide from fires, or radiation. The same blast would kill most people who are using basements affording 5 psi protection over an area of about 58 square miles. Myth number 5. Because some moderate H-bombs are over 1,000 times as powerful as the A-bomb that destroyed most of Hiroshima, these H-bombs are 1,000 times as deadly and destructive. Facts. A nuclear weapon 1,000 times as powerful as the one that blasted Hiroshima, if exploded under comparable conditions, produces equally serious blast damage to wood frame houses over an area up to about 130 times as large, not 1,000 times as large. Okay. For example, airbursting a 20 kiloton weapon at the optimum height to destroy most buildings would destroy or severely damage out to about 1.42 miles from ground zero. The circular area of at least severe blast damage will be about 6.33 square miles. The explosion of a 20 kiloton weapon releases the same amount of energy as 20,000 tons of TNT. 1,000 20 kiloton weapons, thus airburst, well separated to avoid overlap of the blast areas, would destroy or severely damage houses over areas totaling approximately 6,330 square miles. In contrast, similar air bursting of one 20 megaton weapon, equivalent in explosive power to 20 million tons of TNT, would destroy or severely damage the great majority of houses out to a distance of 16 miles from ground zero. The area of destruction would be about 800 square miles, not 6,330 square miles. Today, few, if any, of Russia's huge intercontinental ballistic missiles, ICBMs, are armed with a 20 megaton warhead. Now, a huge Russian ICBM, the SS-18, typically carries 10 warheads, each having a yield of 500 kilotons, each programmed to hit a separate target. See James Weapon Systems, 1987-88. Okay, myth number 6. A Russian nuclear attack on the United States would completely destroy all American cities. Facts. Take a drink. As long as Soviet leaders are rational, they will continue to give first priority to knocking out our weapons and other military assets that can damage Russia and kill Russians. To explode enough nuclear weapons of any size to completely destroy American cities would be an irrational waste of warheads. The Soviets can make better use of most of the warheads that would be required to completely destroy American cities. The majority of those warheads probably already are targeted to knock out our retaliatory missiles by being surface burst or near surface burst on the hardened silos located far from most cities and densely populated areas. Unfortunately, many military significant targets, including naval vessels and port facilities, bombers and fighters on the ground, air bases, and airport facilities that can be used by bombers, army installations, and key defense factories, are in or close to American cities. In the event of an all-out Soviet attack, most of these soft targets would be destroyed by air bursts. Air bursting, see figure 1.4. Air bursting a given weapon subjects about twice as large an area to blast effects severe enough to destroy soft targets as does surface bursting. Figure 1.1, the same weapon. Fortunately for Americans living outside blast and fire areas, air bursts produce only very tiny particles. Most of these extremely small radioactive particles remain airborne for so long that their radioactive decay and wide dispersal before reaching the ground make them much less life-endangering than the promptly deposited larger fallout particles from surface and near-surface bursts. However, if you are a survival-minded American, you should prepare to survive a heavy fallout wherever you are. Unpredictable winds may bring fallout from unexpected directions, or your area may be in a hotspot of life-endangering fallout caused by rainout or snowout of both small and tiny particles from distant explosions. Or the enemy may use surface or near-surface bursts in your part of the country to crater long runways or otherwise disrupt U.S. retaliatory actions by producing heavy local fallout. Today, few, if any, of Russia's largest intercontinental ballistic missiles, ICBMs, are armed with a 20 megaton warhead. A huge Russian ICBM, the SS-18, typically carries 10 warheads, each having a yield of 500 kilotons, each programmed to hit a separate target. See James Weapon Systems, 1987-88. However, in March 1990, CIA Director William Webster told the U.S. Senate Armed Services Committee that the USSR's strategic and modernization program continues unabated, and that the SS-18 Mod 5 can carry 14 to 20 nuclear warheads. The warheads are generally assumed to be smaller than those of the older SS-18s. Myth number 7, I think it is. So much food and water will be poisoned by the fallout that people will starve and die even in fallout areas where there is enough food and water. Facts. If the fallout particles do not become mixed with the parts of food that are eaten, no harm is done. Food and water in dust-tight containers are not contaminated by fallout radiation. Peeling fruits and vegetables removes essentially all fallout, as does removing the uppermost several inches of stored grain into which fallout particles have fallen. Water from many sources, such as deep wells and covered reservoirs, tanks, and containers, would not be contaminated. Even water containing dissolved radioactive elements and compounds can be made safe for drinking by simply filtering it through Earth, as described later in this book. Myth number 8. Most of the unborn children and grandchildren of people who have been exposed to radiation from nuclear explosions will be genetically damaged, will be malformed, delayed victims of nuclear war. Facts. The authoritative study by the National Academy of Sciences, a 30-year study of the survivors of Hiroshima and Nagasaki, was published in 1977. It concludes that the incidence of abnormalities is no higher among children later conceived by parents who were exposed to radiation during the attacks on Hiroshima and Nagasaki than is the incidence of abnormalities among Japanese children born to unexposed parents. This is not to say that there would be no genetic damage, nor that some fetuses subjected to large radiation dose would not be damaged, but the overwhelming evidence does show that the exaggerated fears of radiation damage to future generations are not supported by scientific findings. Myth number 8. Overkill would result if all the US and USSR nuclear weapons were used, meaning not only that the two superpowers have more than enough weapons to kill all of each Earth's other's people, but also that they have enough weapons to exterminate the human race. This is a long video. There's 3 more pages. Okay, facts. Statements that the U.S. and the Soviet Union have the power to kill the world's population several times over are based on misleading calculations. One such calculation is to multiply the deaths produced per kiloton exploded over Hiroshima or Nagasaki by an estimate of the number of kilotons in either side's arsenal. A kiloton explosion is one that produces the same amount of energy as does 1,000 tons of TNT. The unstated assumption is that somehow the world's population could be gathered in circular crowds, each a few miles in diameter with a population density equal to downtown Hiroshima or Nagasaki, and then a small Hiroshima-sized weapon would be exploded over the center of each crowd. Other misleading calculations are based on exaggerations of the dangers from long-lasting radiation and other harmful effects of nuclear war. Myth number 9. Blindness and a disastrous increase of cancers would be the fate of survivors of a nuclear war because the nuclear explosions would destroy so much of the protective ozone in the stratosphere that far too much ultraviolet light would reach the Earth's surface. Even birds and insects would be blinded. People could not work outdoors in daytime for years without dark glasses and would have to wear protective clothing to prevent incapacitating sunburn. Plants would be badly injured and food production greatly reduced. Facts. Large nuclear explosions do not inject huge amounts of nitrogen oxides, gases that destroy ozone, into the stratosphere. However, the percent of the stratospheric ozone destroyed by a given amount of nitrogen oxides has been greatly overestimated in almost all theoretical calculations and models. For example, the Soviet and U.S. atmospheric nuclear test explosions of large weapons in 1952 to 62 were calculated by Foley and Ruderman to result in a reduction of more than 10% of total ozone. See M.H. Foley and M.A. Ruderman, Stratospheric Nitrogen Oxide from Past Nuclear Explosions, Journal of Geophysics. Yet observations that they cited showed no reductions in ozone, nor did ultraviolet increase. Other theoreticians calculated sizable reductions in total ozone, but interpreted the observational data to indicate either no reduction or much smaller reductions in their calculated ones. A realistic, simplified estimate of the increased ultraviolet light dangers to American survivors of a large nuclear war equates these hazards to moving from San Francisco to sea level at the equator, where the sea level incidence of skin cancers, seldom fatal, is highest, about 10 times higher than the incidence at San Francisco. Many additional thousands of American survivors would get skin cancer, but little or no increase in skin cancers might result if in the post-attack world, deliberate suntanning and going around hatless went out of fashion. Furthermore, almost all of today's warheads are smaller than those exploded in the large weapons tests mentioned above. Most would inject much smaller amounts of ozone-destroying gases or no gases into the stratosphere, where ozone deficiencies may persist for years. and nuclear weapons smaller than 500 kilotons result in increases due to smog reactions in upper tropospheric ozone. In a nuclear war, these increases would partially compensate for the upper level tropospheric decreases, as explained by Julius S. Chang and Donald J. Wobbles of Lawrence Livermore National Laboratory. Myth number 10. Unsurvivable nuclear winter surely would follow a nuclear war. The world will be frozen if only 10 megatons, less than 1% of all nuclear weapons, are used to ignite cities. World enveloping smoke from fires and the dust from surface bursts will prevent almost all sunlight and solar heat from reaching the Earth's surface. Universal darkness for weeks. Sub-zero temperatures, even in summertime. Frozen crops, even in the jungles of South America. Worldwide famine. Whole species of animals and plants exterminated. The survival of mankind is in doubt. Facts. Unsurvivable nuclear winter is a discredited theory that, since its conception in 1982, has been used to frighten additional millions into believing that trying to survive a nuclear war is a waste of effort and resources, and that only by ridding the world of almost all nuclear weapons do we have a chance of surviving. Non-propagandizing scientists recently have calculated that the climatic and other environmental effects of even an all-out nuclear war would be much less severe than the catastrophic effects repeatedly publicized by popular astronomer Carl Sagan and his fellow activist scientists, and by all the involved Soviet scientists. Conclusions reached from these recent recent realistic calculations are summarized in an article, Nuclear Winter Reapprised, featured in the 1986 summer issue of Foreign Affairs, the prestigious quarterly of the Council of Foreign Relations. The authors Starley L. Thompson and Stephen H. Schneider are atmospheric scientists with the National Center for Atmospheric Research. They showed that on scientific grounds, the global apocalyptic conclusions of the initial nuclear winter hypothesis can now be relegated to a vanishing low level of probability. Their models indicate that in July, when the greatest temperature reductions would result, the average temperature in the United States would be reduced for a few days from about 70 degrees Fahrenheit to approximately 50 degrees. In contrast, under the same conditions, Carl Sagan and his associates and the Russian scientists predicted a resulting average temperature of about 10 degrees below 0 Fahrenheit, lasting for many weeks. Persons who want to learn more about possible post-attack climatic effects also should read the fall 1986 issue of Foreign Affairs. This issue contains a long letter from Thompson and Schneider, which further demolishes the theory of catastrophic nuclear winter. Continuing studies indicate that there will be even smaller reductions in temperature than those calculated by Thompson and Schneider. Soviet propagandists promptly exploited belief in unsurvivable nuclear winter to increase fear of nuclear weapons in war and to demoralize their enemies, because raging city firestorms are needed to eject huge amounts of smoke into the stratosphere, and thus, according to one discredited theory, prevent almost all solar heat from reaching the ground. The Soviets changed their descriptions of how a modern city will burn if blasted by a nuclear explosion. Figure 1.6, which is right here. So here's the translation of it. Radioactive contamination occurs in the area of the explosion and also along the trajectory of the cloud, which forms a radioactive track. Figure 1.6, drawing with caption in a Russian civil defense training film strip. The blazing fires ignited by a surface burst are shown in standing buildings outside the miles-wide zone of complete destruction, where the blast hurled rubble only smolders. It's a pretty ominous illustration. Okay, so figure 1.6 pictures how Russian scientists and civil defense officials realistically described, before the invention of nuclear winter, the burning of a city hit by a nuclear weapon. Buildings in the blasted area for miles around, ground zero will be reduced to scattered rubble, mostly of concrete, steel, and other non-flammable materials that will not burn in blazing fires. Thus, in the Oak Ridge National Laboratory translation, of Civil Defense, second edition, 500,000 copies. Moscow, 1970, by Egorov, Shlyakov, and Alabim. We read, fires do not occur in zones of complete destruction that are characterized by an overpressure exceeding 0.5 kilograms per centimeter squared, approximately 7 psi, because rubble is scattered and covers the burning structures. As a result, the rubble only smolders and fires as such do not occur. Okay, last page. Firestorms destroy the centers of Hamburg, Dresden, and Tokyo. The old-fashioned buildings of those cities contain large amounts of flammable materials, were ignited by many thousands of small incendiaries and burned quickly as standing structures well supplied with air. No firestorm has ever injected smoke into the stratosphere or caused appreciable cooling below its smoke cloud. The theory that the theory that smoke from burning cities and forests and dust from nuclear explosions would cause worldwide freezing temperatures was conceived in 1982 by the German atmospheric chemist and environmentalist Paul Crutzen, and continues to be promoted by a worldwide propaganda campaign. This well-funded campaign began in 1983 with televised scientific political meetings in Cambridge and Washington featuring American and Russian scientists. A barrage of newspaper and magazine articles followed, including a scaremongering article by Carl Sagan in the October 30th, 1983 issue of Parade, the Sunday tabloid read by millions. The most influential article was featured in the December 23rd, 1983 issue of Science, the weekly magazine for the American Association for the Advancement of Science. Nuclear winter, global consequences of multiple nuclear explosions, by 5 scientists, R.P. Turco, O.B. Toon, T.P. Ackerman, J.B. Pollack, and Carl Sagan. Significantly, these activists listed their names to spell TTAPS, pronounced TAPS, the bugle call proclaiming lights out or the end of a military funeral. Until 1985, non-propagandizing scientists did not begin to effectively refute the numerous errors, unrealistic assumptions, and computer modeling weaknesses of the TAPS and related nuclear winter hypotheses. A principal reason is that government organizations, private corporations, and most scientists generally avoid getting involved in political controversies or making statements is likely to enable anti-nuclear activists to accuse them of minimizing nuclear war dangers, thus undermining hopes for peace. Stephen Schneider has been called a fascist by some disarmament supporters for having written Nuclear Winter Reprised, according to the Rocky Mountain News of July 6, 1986. 3 days later, this newspaper that until recently featured accounts of unsurvivable nuclear winter criticized Carl Sagan and defended Thompson and Schneider in its lead editorial and study of nuclear winter. Let scientists be scientists. In a free country, truth will out, although sometimes too late to effectively counter fast-hitting propaganda. Excuse me. Effective refutation of nuclear winter also was delayed by the prestige of politicians and of politically motivated scientists and scientific organizations endorsing the TAPS forecast of worldwide doom. Furthermore, the weaknesses in the TAPS hypothesis could not be effectively explored until adequate government funding was made available to cover costs of lengthy, expensive studies, including improved computer modeling of interrelated, poorly understood meteorological phenomena. Serious climatic effects from Soviet-U.S. nuclear war cannot be completely ruled out. However, possible deaths from uncertain climatic events are a small danger compared to the incalculable millions in many countries likely to die from starvation caused by disastrous shortages of essentials of modern agriculture sure to result from Soviet-American nuclear war, and by the cessation of most international food shipments. Okay, so that's it for that chapter. I'll cover chapter 2 next, psychological preparations. That's it. That was a longer video, almost 40 minutes. So, I'll cover the next chapter probably tomorrow, and I hope that this helps, and I hope that this is all coming out well. That people who want to read the book can do so. Okay, yeah, that's it for now. Thanks for watching.